All right, now this video is going to be about simplifying radicals. So we did some simplifying rational exponents. We're going to simplify with our radicals. Now, they're kind of similar. What we're interested in is this number out here. All right, so that 3, what that represents is that's a cube root. Cube root means you have to have 3 things that are exactly the same, and we know in order to have that value come out. All right, so basically it's like the cube root of 8. What number did I multiply 3 times to get to the cube root of 8? That was 2. 2 times 2 times 2. So you need sets of 3. Once you have something that creates a set of 3, that can actually be taken out of the radical, outside of the radical. So that's what we're going to first do. We're going to break down 32 into prime numbers. I'm going to start with 2 and 16. Then 16 gets broken up as 2 and 8. 8 gets broken up as 2 and 4. 4 gets broken up as 2 and 2. Now, once you have broken up a number, you don't look at it anymore. You're interested in all of our primes. Now, the 3 means that we need a set of 3. Now, you can see that I have a set of 3 right there. Now, that means I can take that value, 2, outside of this radical. All right, now the 2 that I did not do anything with, I'm going to leave a little space here for this cube root. I have to multiply those 2 numbers back together. So I actually end up getting a 4. Now, the next part is the same thing. I've got all of these x's. I have 16 of them. I want to see how many sets of 3 I can create. So we're basically trying to see how many times does 3 go into 16. All right? And if you do that properly, you're going to end up getting 5. So x to the 5th. Now, the problem is that 3 doesn't go into 16 evenly. All right? When I do 3 times 5, that's really a total of 15. I have 5 sets of 3 x's. All right? That's a set of 3, another set of 3, another set of 3. I get 5 of those. That's 15 total. I had 16 underneath. So what that means is that leftover x is going to stay underneath that radical. I'm going to do the same thing with my y's now. You can see that I got a total of 9 y's. The nice thing is that 3 goes into 9 an even amount. Okay, we have 3 sets of those y's with no remainder. All of the y's came out. So this simplifies to 2x to the 5th, y cubed, and then the cube root of 4x. All right, so once again, if we're trying to think about this stuff, like x to the 16th, there are 5 sets of 3. 5 times 3 is 15, with 1 remainder. For the other one, y to the 9th, there was 3 sets of 3. 3 times 3 is equal to 9, so there is no remainder. And that's how I was able to come out with x to the 5th and y cubed. So that's simplifying using our radicals.